Alright, welcome to
KidMath101.
KidMath101. So today we're in section 16.3 of our Art of Problem Solving algebra book on composition of functions. We have a couple of tough examples to work through today, so I thought we'd just do a fun example for the movie. Okay?
Alright.
And we're going to let f of x equal a to the x. And we're going to do f of a. So we're going to get this interesting sequence that goes a to the 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 a, dot, 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 all the way up to the a. And then if we do it for infinity, an infinite tower.
Yeah.
Pretty neat, right?
Yeah.
Grab an eraser real quick. But this doesn't always work. You can imagine, let's take two simple examples. 1 to the 1 to the 1 to the 1 all the way up is going to equal what? 1. And how about something like 5 to the 5 to the 5 to the 5 all the way up?
It's going to equal a really large number.
All the way up.
To infinity.
Yeah.
That'll be infinity.
Looks like it'll be infinity. I mean, if we just look at the first couple examples, we get 5. 5 to the 5th is already huge, right?
Yeah.
5 to the 5 to the 5 is...
Even
So it looks like this is going to be...
infinity.
Infinity. So there's an interesting question that this Cornell professor, Stephen...
Does that mean 1 equals infinity?
No, that does not mean 1 equals infinity, because remember that was 1 to the 1 to the 1 and 5 to the 5 to the 5. Yes, 1 does not equal infinity. But this Cornell math professor, sorry, Stephen Strogatz, over the summer posted a neat problem about when does this work and when does it not work. So if we have this function, let's say it goes x to the x to the x to the x to that, and let's say it equals some number c, can we figure out when that happens? Like when we put in 5, it seems like we're going to get infinity. When we put in 1, we get some sort of finite number.
That's interesting.
Yeah. So do you have any idea how you might even think about dealing with an equation like this? Because this is just kind of fun.
Not really.
Okay, we know x to the x to the x to the x all the way up equals c. So we're going to try to solve it.
Well, how is this infinite sequence going to equal a finite number?
Yeah, that's why it's interesting, actually. So we have an infinitely many sequence of x powers on the top. What if I take away the first one? What do all the powers equal?
All the powers is still x to the x to the x to the x to the x. It's exactly the same thing.
Which is?
C.
C. So this says x, if it converges, then x to the c is going to equal c. And now to solve for x, I just take the 1 divided by c's power of both sides. Right?
Yeah.
So x equals c to the 1 over c. Do you see?
Yeah.
Okay, so this is an interesting function, c to the 1 over c. And if we graphed it, and we're going to go do that on Wolfram Alpha right now, we're going to see, and I'm going to just do it at 1, because below 1 it gets a little weird. But it goes up, and then it goes down. But it has a maximum value, and that's what we're going to try to find. Because as c gets larger, once you cross some point, c to the 1 over c gets smaller, so that wouldn't really seem to make sense, that as x would get larger, that some bunch of powers would get smaller.
That's weird.
But it does make sense in the beginning that if you get bigger than 1, it would grow, it would get bigger, right?
Yeah.
So we're going to try to see what happens at this maximum point here, whatever that is.
Looks kind of like somewhere around 2.
Well, yeah, maybe, but I didn't really label what the graph was, but we'll see. We'll go see it right now on Wolfram Alpha, okay?
Alright.
Alright, let's go see. Now you have to remember, it's x is c to the 1 over c.
Yep.
Okay, so here I've graphed x equals c to the 1 over c as c goes from 1 to 5.
Yep.
Okay, and you can see that it goes up and then it starts coming back down. And that's what Wolfram Alpha helps us understand. And it turned out your guess was right. The maximum looks like it's somewhere around 2. I bet, never even tried this before, but I bet if I put, instead of graph, I put max in, I bet Wolfram Alpha will tell us what the maximum is. Hey, the maximum occurs at this strange number
E.
E. Do you know what E is?
It's around 2.
Well, it's 2.7. 2.71828. So that's kind of neat, right? So the maximum value of this is at E, and the height of that is about
1.45.
1.45. Let's see if we can zoom in a little bit. Maybe we'll go E, since I know E is about 2.7, I'll go from maybe 2.5 to 2.8. See if we can zoom in and really see the maximum. Oh, there it tells us 2.71828. And the maximum is 1.44467.
It's really close.
So that's interesting. So now that we know the maximum value of that graph, what happens if we put in numbers on either side of that? So let's say if I let x equal 1.44467, and I look at x to the x to the x to the x to the x, the x to the x to the x to the x, just say. What does Wolfram alpha tell us about that? Hey, it tells us it's about 2.25.
It's close.
From our equations, it says this should eventually converge to E, 2.71. So it is getting close. But what if I go on the other side? What if I just go to, like, I don't know, let's just round up and go to 1.5. Okay?
All right.
So now I'm on the other side.
Now what happens?
Now what happens? 3.64. To the x to the x. 5.91. Does this seem like it's converging, or does it seem like it's just getting bigger and bigger?
It's getting bigger.
2 more x's on there. 86 point. So just right on the other side, I went from 1.44, where it looks like from our math it was going to converge to E.
But now you went
And now
up.
I go to just up a little bit to 1.5, and it goes to looks like it's going to infinity.
Yeah.
How cool is that?
Cool.
So that's another just kind of fun, interesting application of composition of functions. This is more just, well, it's a little different, but it's close enough. But it shows you something really neat. And you know what's else about this problem is really surprising?
What?
Going to the other side, going down to 0, this function x to the x to the x to the x also has really crazy behavior too. So maybe someday we'll talk about that.
Yeah.
But this was fun. Like I said, we're going to do a couple of tricky examples today, so I want to do a fun one for our movie.
All right.
Good job.